everyone, Dr. Burns here, and we are ready to start our videos for differential equations. I'm going to start with section 1.1, and as you go through these videos, make sure you're completing the guided notes in your course packet. I'm going to try to make it so these videos aren't longer than about 10 or 15 minutes, and we'll do a little bit more practice with some of the examples in class and just try to hit some of the key points in the videos. So what is a differential equation? What the heck are we going to be looking at in this class? Well, a differential equation is essentially just an equation that contains some kind of derivative. So equations that contain derivatives are what we mean by a differential equation, where there's some sort of derivative in that equation. It could be a first derivative, it could be a second derivative, could be a third derivative, it just depends. And we'll start with first derivatives to keep things simple and kind of work our way up as we go through the course. Our goal is to be able to solve a differential equation, meaning we get rid of the derivative and work backwards and figure out what the original function would have been to produce that differential equation. Some of these are really hard to compute by hand. We're going to learn some basic techniques in this first unit to solve some of these by hand, but sometimes we're just going to look at graphs and analyze the graphs that way and make predictions based on the graphs. Sometimes we're going to use technology to solve the differential equations and then just kind of look at interpreting what the differential equations tell us about whatever phenomenon they're modeling. Let's start with a simple example here. It says dy dt equals 0.028. Now, 0.028y. This could represent a lot of different things, but they're telling us that this represents the balance y in dollars in a bank account at any time t in years. So first of all, what does this mean? Well, we can think of this dy dt. Remember, derivatives always represent a rate of some kind. So we can think of this as telling us how fast the balance in the account is changing. And the units are important here. It would be in dollars per year. Dy dt, y is dollars, t is years. So the rate of change, dy dt, would be dollars per year. So we could say it's how fast the balance in the account is changing in, I'm going to say dollars per year, just like that. So B says find, or what is the value rather, when, let me try that again. When the value of the bank account is $2,000, what is dy dt? So I'm going to substitute that in. So dy dt is equal to 0.028 times 2,000, which gives me 56. And remember, that would be in dollars per year. So what could we say then? We could say that that means when we have $2,000 in the account, the balance is, and is it increasing or is it decreasing? Well, because the derivative is positive, that means it would be increasing, right? So we can say when in the account the balance is increasing at a rate of $56 per year. And this would be a typical equation in like a business calc class, for example, a differential equation where they're talking about how fast an account maybe is changing. A couple of key terms that you need to know. So this is a really important page. Make sure you take good notes here and use this as a reference as we go, because we're going to see these again throughout the course. A lot of vocabulary to get used to. It's a little overwhelming at first, but you'll get the hang of it. As we go through the course, we'll just use these terms again and again. So if an equation involves the derivative of one variable with respect to another, then the former, the first variable there, would be called the dependent variable. Same as what you've always used. You've got an independent and a dependent variable, and the latter is called the independent variable. So you do just need to be able to identify which is which when you look at the differential equation. A lot of times it's x and y, but it could be anything. It depends on how they write the equation. So this example right here that we have, this is a differential equation. It's also called a second order differential equation because it's got the second derivative in it. So the independent variable would be t. I assume that means time, but I don't know. It could mean anything. All I know is that that's the independent variable because it's the derivative of x with respect to t. So t is the independent variable and x is the dependent variable. A and k are also called coefficients, right? Coefficients, just like in algebra, coefficients on a variable. In this example, now this is notation you haven't seen necessarily before, but what this is called a partial derivative. So if you have an equation that is in two variables, so f of x comma y. So let's say f of x, y, let's say f is equal to x squared plus y squared. Let's just keep it simple. That would be a multivariable equation in terms of two variables, and x and y are both the independent variables. So the independent variables are x and y. In this example, u is the dependent variable. So this first expression is called the partial derivative of u with respect to x. We'll talk a little bit more about partial derivatives later on, so you don't need to have a total idea of what that is right now. All I want you to do is be able to identify these independent and dependent variables. U is the name of the function, okay? So u is the dependent variable, x and y are the independent variables. So this is the partial derivative of u with respect to x, and this is the partial derivative of u with respect to y. And we'll come back to that later on. And you can see equals x and 2y. So x minus 2y. X and y are your independent variables. A differential equation involving ordinary derivatives, in other words, with respect to a single variable. What we studied in Calc 1 and Calc 2, those were ordinary derivatives with respect to a single variable, dy, dt, dx, dt, whatever, okay? That is called an ordinary differential equation. And the vast majority of what we're going to see in this class involves ordinary differential equations. We haven't taken Calc 3 yet, and so we're not going to do a whole lot with partial differential equations or partial derivatives, but there are some situations where you may see an equation involving a partial derivative. So I want you to be familiar with the term. And that's actually what you saw here. This is called a partial differential equation. So a differential equation involving partial derivatives is called a partial differential equation. And a lot of times you'll see that we abbreviate, we call this a PDE, as I just wrote above, and an ordinary differential equation, which is most of what we're going to work with, is called an ODE. Sometimes we'll write that. The blank of a DE refers to the highest order derivatives present in the differential equation. Well, that would be the order. I mentioned that term earlier, and that just means what is the highest derivative you have. Is it a first derivative? Then it's a first order differential equation. Is it a second derivative? Then it's a second order differential equation. In this example here, this is a first order because dy dx is the only derivative I have, the highest order derivative. This is called a second order differential equation because I've got a second derivative in the equation. A differential equation is considered linear, and we're going to start with those in chapter 2. Linear if the occurrence of the dependent variable is linear. So these are kind of the standard forms for linear differential equations, and we'll come back to these later on. But what I want you to focus on is this variable right here. That's the dependent variable, and notice that it's just y. It's not y cubed, it's not y squared, it's not square root of y or anything like that. It's simply y, and that's all you have in the equation. Same thing here. You've got a y by itself, y to the first power. That's what makes it linear. Otherwise, the differential equation is said to be nonlinear. So these are two examples here where you have nonlinear differential equations. This one because you've got the y cubed term. This one, a little bit tricky here, but this is nonlinear, and the reason is because that this is in front of the derivative term, the dy dx term. In order to be linear, that y term has to be by itself in front of, either completely by itself with a 1 in front of it, or with a function of strictly x in front of it. And that's what this p of x represents in these two equations. So because this one is in front of the dy dx, that means it would be nonlinear. And we will practice classifying these and talking about these a little bit more in class tomorrow. So make sure you bring your notes with you, and I will see you then.